Hello everybody, this is 2.3 estimating derivatives, and if you're wondering why there are answers on the worksheet, is because I was close to finishing the video and it abruptly ended. I was probably over 20 minutes and it just, I don't know, it stopped. And I usually do like, you know, 5 minute chunks or 10 minutes. But at this time, I was doing it in one take, and I don't know, something happened, and so I'm not gonna redo all of this. I'm just gonna explain, and hopefully you can understand without me having to do it all over again. Okay, so for questions 1 through 9, you have to estimate the derivative at the given point by using a calculator. Now, these questions are pretty easy, right? All you have to do is use a calculator and then plug in the function into your derivative, your math 8, and then you're gonna find the derivative at that point. Now, I'm gonna show you how to do just that. So, right here in our TI-84, we have math right under the green button, alpha. We have math. And then if you see 8, it says end derivative. So you want to press 8, and now you see this. When you do derivatives, you're going to do it with respect to x. And then right here, you're going to plug in your function in the parentheses. So what is our function? Well, I'm going to do the first 3 just so you can see. But, I mean, there's no work to show anyway. So, okay, let's take question 1. F of x equals x times the square root of 2 minus x. Find f prime of negative 10. So our function is x times square root of 2 minus x. And then x is negative 10. And then, boom, we plug it in. We get 4.907. And something that I mentioned in the video before I got corrupted was that in calculus, you're going to truncate, which means you cut for whatever. I'm sorry. You cut every number after the third decimal. So if we truncate this right here, we're going to get 4.907. That's where you truncate it. So you stop after 3 decimals. And then the other way, which is acceptable as well, is to round up. So you can do 4.907. Round up or round down, whatever is, appropriate. So 4.907, that would be um if you round down. So the truncate and rounding in this question is the same. But if it was, let's say, 4.9075, 4.908 would be acceptable since you're rounding up to the third decimal. All right, next question. We have secant of 5x. Now, I don't see a secant button on my calculator. You shouldn't have one on yours. If you do, great, but I don't think there's a calculator with the secant button. And so, to make up for that, we're going to write secant in its cosine form. So secant x is equal to 1 over cosine x. And then we have secant of 5x. 5x is our inner function. So we're going to keep that 5x there. So 1 over cosine 5x is equivalent to secant of 5x. Okay? Now knowing that, we're going to do math 8, derivative with respect to x, and then we're going to do 1 over cosine of 5x. And then this is at x equals 2, right? Because we're trying to find f prime of 2. So our x is going to be 2. And you get negative 3.8636822218. So what would be your answer if you truncate it? If you said negative 3.863, you would be correct. If you round it up, what would be your answer? You would get negative 3.864. Either or is acceptable. There's no wrong answer between those two. Remember, truncate stops after the third value after the decimal, and then rounding up or down with the third decimal is also acceptable. Cool. And then the last example I'm gonna do is I guess we could do number 3. So ln of square root of x. So we're gonna do math 8 again, and then with respect to x, then it is ln square root of x. And then this is at x equals 1. Oops. Okay, x equals 1. So we get 0 0.5. 0 0.5. And so that's how you do it. Oh, I want to show you how to do 8, because 8 is a little bit weird if you're not too comfortable with, you know, trying to get sine squared x on the calculator. So, notice, I put sine, but if I go back with the arrow, it doesn't let me go in between the parentheses and the sign. And the problem is that our equation here is sine squared x. So how do we get that square in? Well, we'd get that square in by putting our inner function as like that, which is x, and then put that square right on the outside. So sine of x squared is the same thing as sine squared of x. And this is how you would do it on the TI-84. Okay, and then our point is at 12.5. And that's going to net us negative 0.132, and then feet per minute. I don't have the answer here, but just trust me on that. All right. Questions 10 through 13 are basic tangent line questions. I guess I'll do the first two, because I kind of feel bad. I wanna show you how to do it, and then the other two, you can just look at the answer. Okay. So if you remember, tangent line is y minus y1 equals m times x minus x1. But I personally like to write it as y equals y1 plus m times x minus x1. It does not matter, both ways are correct. I just like to have my y equals and then everything on the right side. That's just how I like it. Okay. So we have our x equals and we have our f of x. So what we don't have is our y coordinate, and we don't have our f prime of 1. So we're going to have to use a calculator here. And I'll show you a little trick if you didn't know. Since we have to use f of x multiple times, we're going to store it as our y1. And so f of x equals ln of 2x divided by 4x. Okay, that is our y1. So now, under the down arrow, you have variables or vars, and you're going to press right on the arrow, and you're going to press 1 function. And then you're going to press 1 again for your y1. And then this right here, y1, that is your function. That is the function that you put in your y equals. And then to get our function value at 1, I'm going to do parentheses 1. And that is going to give us 0.173. And so y equals 0.17. Oh goodness. Y equals 0.173. Now, it's just a tangent line. We're not asked to solve for anything. So we're just going to truncate it here. We're not going to make that big of a deal of not putting the whole thing down. Okay. And then we have to find our derivative at 1. So we're going to do math 8 respect to x. And you can just put in y1. Remember, you go to variables, y variables, function, and then y1. Put in your y1, and then at x equals 1, you get your derivative to be 0.076. So plus 0.7, sorry, 0.07 times x minus 1. And there you go. That is how you do number 10 and how you do any tangent line question with the calculator. Next up, we have cosine of tangent of x. So we're going to clear that, and we're going to put cosine of tangent of x, parentheses, parentheses. Okay. Remember, you want to find your y value, so you go to variables, y variables, function, y1. And then this is at x equals 2, so we're going to do parentheses 2 equals. So that's negative 0.576. Y equals negative 0.576. Put this into, we're going to put this function now into into your derivative. So math 8, respect to x, variables, function y1. And then we're going to do at x equals 2. Enter. And you get 4.718 plus 4.718 times x minus x1, which is 2. And that is how you solve these types of questions. Let me know if that makes sense. If it doesn't, um, you can reach out to me and I can explain it. Um, and then 12 and 13 operate in the same way. All right. Questions 14 through 19 entail estimating derivatives at a given point using tables. Okay. How do you do this? Well, you want to take two values that are that have, okay. You want to take two values to approximate the value in between. Okay, let me use an example for that. You have v prime of 8. V prime of 8 can be approximated by the average rate of change, which is close to 8. So that may sound, complicated, but it's not. So 8 is between 7 and 9, right? So you add 1 to 7, you subtract 1 from 9, and you get 8. So 8 is right in the middle. So your closest approximation given this information is going to be the average rate of change of f of 9 minus f of 7 over 9 minus 7. Again, this is going to be an estimate because you aren't going to know. You're not going to know the values like that are right next to it. You're not going to know 8.01. You're not going to know 7.999. But f of 9 and f of 7 are close enough to 8 that you can make a pretty good estimate of what f prime, or in this case v prime of 8, is. Okay? And also one thing to note is that you can only do this if your function is differentiable. Now this doesn't tell you it's differentiable, but it's just practice, so assume it is. Okay. So I already kind of went over v prime of 8, but I'll go into more depth, I guess. So we have v of 9 minus v of 7 over 9 minus 7. I used f by accident, but it's v. And that answer that you get is going to be your approximate instant rate of change at 8. V prime of 3.5. Well, you have 3 and 4, which is the same distance away from 3.5. So I go to the right, 0.5, I get 3.5. I go to the left, 0.5, I get 3.5. So 3.5 is right there. 3 and 4 are going to be your best. Those are going to be your best estimates for v prime of 3.5. Okay. Another question. You're just given values, t of x in degrees Celsius, and then x is in centimeters. So t prime of 17. Take a guess and try to see which two values you're going to use. Oh, I have them. I have the answers there, but try to see if you can. If I were to ask you why you chose those two values, try to see if you can answer that. Give me the reason. Okay. Well, you chose 23 and 11 because that gives us our best approximation for t prime of 17. You go to the right, 6 units, you get 17. Go to the left, 6 units, and you get 17. And so 17 is right in the middle of these two values. Okay. So you're just gonna find the average rate of change 20 of 23, t of 23 and t of 11, and that's gonna give you your approximate instant rate of change at 17. Now 24.5. See if you can find which two values. Hopefully it's starting to become easier to recognize. Okay. If you haven't recognized, 23, 26 are two values that you will use to approximate 24.5. It's right 1.5. It's left 1.5, and you get 24.5. So that's usually your indicator. Now, in some cases, it's not going to be exactly this. They're not going to be the same distance away. However, if it is the same distance away, that guarantees. But sometimes you'll have, let's say, 22 and 26. You're still going to use those two numbers to approximate 24.5 because 24.5 lies within that range. Okay. S prime of 1.5. Now, I like this question because it introduces a new concept of rates and you have to express the units correctly. So, S prime of 1.5, if you can't tell, should be easy by now. You're going to use 0 and 3. 1.5 is right in the middle. It's in between 0 and 3. So you're going to use S of 3 and S of 0 and find the average rate of change between those two to get your approximation of the instant rate of change at 1.5. Now your answer is going to be 5. However, you are given a rate here, students per year. That's your S of t. So if you find the derivative of t, what is your unit going to be? It's going to be students per year squared because you're finding the derivative, right? So it's going to be an, another rate. So you're going to find the rate of a rate. So you're going to have students per year per year. Okay? And the same thing for S prime of 11. So you would use 7 and 15, right? 11 is right in between 7 and 15. You're going to use these two and these two. 17 again, another rate you're gonna use you're gonna for 47.5 you're gonna use these two. It keeps doing that. It's annoying. You're gonna use those. 47.5 is in the middle. And then remember, you're gonna look for this range for your x value, right? You're not gonna look for 47.5 in PFT. You're gonna look for that in days. Your x, whoops, your years. Okay. And the next one, we have another rate, gallons per second. W prime of 20, right here. 10, 20, 30. 20 is in between 10 and 30. And you're going to use your x to know that 20 is in between 10 and 30. You're going to use that average rate of change. Okay? All right. Now, we are going to get to the test prep, which should be fun. Now, let's read this. Let f and g be the functions defined by f of x equals negative 1 half x cubed plus 3x plus 1 and g of x equals e to the x over 2. Let h be the vertical distance. H is the vertical distance between the graphs of f and g for 0 to 2. Find the rate at which h changes with respect to x when x equals 1.5. Alright, so to find the rate at which h changes, we need to have an h function. Well, what is the h function? Well, we know that h is the distance between f and g, the vertical distance that is. And so, it would be safe to assume that our h of x is this function right here minus this function right here. So you're going to do top minus bottom to get your h of x. So h of x is equal to top function minus bottom function. And this topic is also, this idea of top minus bottom is also seen in Unit 8 when you get to applications of integrals and volume and area. So it's good to know these kind of things. So top minus bottom is going to give you your h. And we are allowed to use a calculator, I believe. But first, let's find the derivative of h. So h prime of x and then f prime of x minus g prime of x. Find the rate at which h changes with respect to x at 1.5. So h prime of 1.5 equals f prime of 1.5 minus g prime of 1.5. Alright, well, looks like we gotta use our calculator here. So f is negative, whoops, okay, negative 1/2 x cubed plus 3x plus 1. Our y2 is going to be our g of x. So g of x is e to the x over 2. Alright. Now we're going to find our derivative. So derivative of our x, which is our y1, at 1.5, and then minus our derivative of, with respect to x, of y2 at 1.5, and that is going to give us approximately negative 1.433. Okay. The graph of y equals 3 minus e to the 5x crosses the x-axis at one point. What is the slope of the graph at this point? Okay, so the key information to note here is it crosses the x-axis at this one point. So we have to find what that one point is. And then it says, what is the slope of the graph at this point? So we have to find our dy dx at the point where y crosses the graph. So how do we find out when y crosses the graph? Well, that's the same thing as finding a zero. A zero crosses the x-axis. So we're gonna solve for our zero. So 3 minus e to the 5x. Now, unless you guys know something I don't, I'm gonna have to use a calculator for this one. Okay. So our thing is, our function is 3 minus e to the 5x. Graph that. Alright, now you see that it does intersect at one point, so we're going to find a 0. Oh, by the way, I did second trace, and then 2. And then we want to select the point. Our left bound is a point above, in this case above the x-axis, and then our right bound is going to be below the x-axis. So that point is going to be 0.2197225, but I don't want to write all of that. So I'm going to second quit, and I'm going to do store, which is second to the bottom, alpha A. So now this is store. Whenever I do alpha A, you're going to get that stored number. So now we can do our math 8 ddx. We're not going to do y1 because I didn't put the function. We're going to do 3 minus e to the 5x. And then our x equals a, which is 0.2197224577. Because we want to find the slope, which is ddx, at the point where our y equals 3 minus e to the 5x crosses the x-axis. And so that is going to be negative 15. So that is going to be dy dx equals negative 15. Okay, for our last question, we have given the function g of x equals x cubed minus e to the x minus sine x, which of the following values of x has a tangent line with the greatest slope? And so we're going to use a calculator again, because unless you know how to calculate negative sine of negative 3 or negative sine of 3, then we're going to have to use a calculator. What is this question asking us? Well, when we find the derivative of this, which you don't need to, actually solve for, because we're going to use a calculator, but I'm going to show you the derivative anyway. So when we solve for this, actually, I don't think this, no, you guys probably don't know the derivative yet up to this point, unless you already took AB. But this is the derivative of g of x. And so the question is asking you, at which x value is your derivative the largest? So we're going to have to compare g prime of negative 3, g prime of negative 1, g prime of 0, g prime of 1, g prime of 3. Okay? And so with that being said, I am going to start from left to right, and I'm going to make sure that I write down all of these values so that we can compare at the end to see which x is going to give us our largest. Sorry, this should be prime. Which x is going to give us our largest slope. Okay. So our function, original function is x to the third minus e to the x minus sine x. Okay? Quit. Okay. So we're going to start with -3. So we use our y1. I'm going to do -3. So -3, we get approximately 28. I'm going to copy this same thing down, and I'm going to use -1 instead. I get 2. Copy, and then we're going to do 0. We get -2. 1. We get -0.25. And then our last one that we're comparing is the derivative of x equals 3. It's approximately 8. And so g prime of -3 is the largest. And so our greatest slope occurs at x equals -3. So I hope this 2.3 was informative. Let me know if you have any questions. I apologize that I wasn't able to do every question step by step, but I do believe that I covered everything that was significant. All right. Thank you for watching.